For today's video lesson, I am going to discuss to you the Quarter 1 Module 2 or the Illustrating Arithmetic Sequence. At the end of this lesson, you should be able to illustrate an arithmetic sequence. Specifically, find the common difference in an arithmetic sequence, find the end term of an arithmetic sequence, and find the arithmetic means. Let us first define the important words and their meaning that you are going to encounter throughout the discussion. First is the arithmetic sequence. It is a sequence where each term after the first is obtained by adding the same constant. Second is the common difference. It is a constant added to each term of an arithmetic sequence to obtain the next term of the sequence. Third is the arithmetic means. These are terms m sub 1, m sub 2, up to m sub k between two numbers a and b, such that a sub 1, m sub 1, m sub 2, m sub k, b is an arithmetic sequence. Based from the definition of the arithmetic sequence from our previous slide, we can obtain this sequence by adding a constant number to the first or to the preceding number. Say for example, we have here the first term 5 and we have a constant number or the common difference which is equal to 3. So to get the next term, we just simply add 3 to 5, that is 8. To get the next term, we just simply add 3 to 8, that is 11. Then add another 3 to get the next term, which is 14, and so on and so forth. So this is now an example of arithmetic sequence. Arithmetic sequence can be finite or an infinite sequence. When we say finite arithmetic sequence, it has the first term and the last term. When we say infinite sequence, it has the first term but no last term. Example, we have here an arithmetic sequence 3, 7, 11, 15, and 19. It is a finite arithmetic sequence since it has a first term and the last term. 3 here is the first term denoted by a sub 1. 7 is the second term denoted by a sub 2. 11 is the third term denoted by a sub 3. 15 is the fourth term denoted by a sub 4. 19 is the fifth and last term denoted by a sub 5. But since it is the last term, it is also a sub n. We can only use this notation a sub n if we are referring to the last term. Now, to find the common difference in an arithmetic sequence, just subtract the first term from the second term from the third term, or subtract two succeeding terms. So, in this example, say for example, we have 7. The number before or the term before 7 is 3. So, 7 minus 3, this is equal to 4. 11 minus 7 is equal to 4. 15 minus 11 is equal to 4. 19 minus 15 is equal to 4. We have here the same difference because it is a constant term in which we call the common difference. So the common difference in this example is 4. Consider the arithmetic sequence 15, 11, 7, and 3 and find the common difference. So, we can get the common difference by subtracting the succeeding term by its preceding term. So, say for example, we have here 11. We can subtract 15 from 11. So, that is 11 minus 15. We can also use 11 and 7 by subtracting 7 by 11. We can also use 3 and 7 by subtracting 3 minus 7. So, in this case, 11 minus 15 is equal to negative 4. 7 minus 11 is equal to negative 4. 3 minus 7 is equal to negative 4. So, the common difference is negative 4. hindi po kailangan na isubtract lahat to get the common difference. You can only use two succeeding term to find the common difference. Suppose we have here an arithmetic sequence 7p plus 2, 5p plus 12, and 2p minus 1. Now, what is the value of p and what is the common difference? Now, to solve for d, we simply subtract two succeeding terms. So, since we have here three terms, we have here the a sub 1, which is 7p plus 2, a sub 2, which is 5p plus 2 or plus 12, and we have here 2p or your a sub 3, which is equal to 2p minus 1. To get the common difference, we simply subtract the second term by the first term or third term minus the second term. Now, since these equations are both equal to d, we can equate a sub 2 minus 1 is equal to a sub 3 minus a sub 2. So, by substitution, your a sub 2 is equal to 5p plus 12 minus your a sub 1, 7p plus 2 is equal to your a sub 3, 2p minus 1 minus your a sub 2, 5p plus 12. Now, let us simplify. So, on the left side of the equation, we can subtract 5p minus 7p, which is equal to negative 2p. We have here 12 minus 2, which is equal to 10. So, plus 10, since that is positive, is equal to 2p minus 1 minus 5p plus 12. We can subtract 2p minus 5p, which is equal to negative 3p. Negative 1 minus 12, that is equal to negative 13. Then, solve for p. We have here, we can add both sides by 3p plus 3p. So, may eliminate ito. Matitira dito is negative 13. So, we have here negative 2p plus 3p is equal to p plus 10. We can subtract both sides by 10 para ma-eliminate ito. So, p is equal to negative 23. Now, let us find the common difference. Let us substitute first the value of p to the given sequence. So, for the first term, 7p plus 2, so that is 7 times negative 23 plus 2. So, 7 times negative 23 is equal to negative 161 plus 2. Negative 161 plus 2 is equal to negative 159. This is your first term. For the second term, 5p plus 12, so we will substitute negative 23 to p. So, 5 times negative 23 plus 12. 5 times negative 23 is equal to negative 115 plus 12. 115 or negative 115 plus 12 is equal to negative 103. This is your second term. For the third term, 2p minus 1, substitute negative 23 to p. So, 2 times negative 23 minus 1. 2 times negative 23 is negative 46 minus 1. Negative 46 minus 1 is equal to negative 47. This is your third term. So the sequence will become negative 159, negative 103, negative 47. Now, what is the common difference? We can subtract negative 103 by negative 159, or we can subtract negative 47 minus negative 103. So, for negative 103 minus 159, this is equal to 56. And for negative 47 minus 103, this is also equal to 56. So, the common difference is equal to 56. So, these are now the answers. P is equal to negative 23 and D is equal to 56. What if you are going to find the common difference of an arithmetic sequence given two non-succeeding terms? So, say for example, we have here the 8th term which is equal to 26 and the 12th term which is equal to 42. Now, to find the common difference given two non-succeeding term, we can let this a sub 8 as your a sub 1. So, if this is your a sub 1, a sub 12 will become your a sub 5. So, this is a sub 1. A sub 8, a sub 9, a sub 10, a sub 11. So, this is a sub 1, a sub 2, a sub 3, a sub 4, and this is your a sub 5, 42. And we can use the general rule of the arithmetic sequence, which is a sub n is equal to a sub 1 plus n minus 1 times d, where your a sub n is the last term, a sub 1 is your first term, n is the number of terms, and d is your common difference. So, in this example, using the general rule, a sub n equals a sub 1 plus n minus 1 times d, a sub n is equal to, your a sub 1 is 26, so substitute 26 to a sub 1, so is equal to 26 plus n minus 1 times d. Now, since we have here a sub 5 as your last term, we can substitute a sub 5 to a sub n. So, a sub 5 is equal to 26 plus a sub 5 is your fifth term, so n will be equal to 5. So, 5 minus 1 times d. Your a sub 5 is equal to 42. So, we can write here 42. Then, simplify. 42 is equal to 26 plus 5 minus 1 is equal to 4d. We can subtract both sides by 26 to eliminate itong 26. So, 42 minus 26 is equal to 16 is equal to 4d. Divide both sides by 4. D is equal to 4. So, the common difference is 4. You can also use the second method in finding the common difference given the two non-succeeding terms. So, to find D, we simply subtract the last term by the first term, which is 26. So, in this case, you will use kung yung original given, kung pang ilan si 42. So, that is 12 minus, kung pang ilan si 26, that is 8. So, D is equal to 42. So, this is from A sub 12 minus A sub 8 over 12 minus 8. So, 42 minus 26, this is equal to 16. 12 minus 8 is equal to 4. So, D is equal to 4. That is the common difference. Now, let us find the general or the nth term of an arithmetic sequence. Arithmetic sequence can be expressed as an equation or rule, and that general rule is A sub n is equal to A sub 1 plus n minus 1 times D, where A sub 1 is your first term, n is the number of terms, D is the common difference, and A sub n is the last term. Let us consider the arithmetic sequence 2, 5, 8, and 11. You are going to find the general term or the arithmetic sequence rule, and you are going to find A sub 6, A sub 8, A sub 10, and A sub 15. To find the general term, let us use the general rule, which is A sub n is equal to A sub 1 plus n minus 1 times D. So we are going to find the first term and the common difference of the given arithmetic sequence. So in this case, your first term is 2. So substitute 2 to A sub 1. So that is 2 plus n minus 1 times the common difference is, we simply subtract two succeeding term, 5 minus 2, 3, 8 minus 5, 3, 11 minus 8 is 3. So the common difference is 3. A sub n is equal to 2 plus, by distributive property, n times 3 is 3n, negative 1 times 3 is negative 3. So, A sub n equals 3n. Combine like terms, 2 minus 3 is negative 1. So, this is now the general rule for the arithmetic sequence 2, 5, 8, and 11. Now, let us find A sub 6. So, from the general rule, you are going to substitute 6 to all n. So, A sub n is equal to A sub 6 is equal to 3 times 6 minus 1. So, A sub 6 is equal to 18 minus 1. A sub 6 is equal to 17. This is now the sixth term. A sub 8 is equal to, so you are going to substitute 8 to all n. So, 3 times 8 minus 1. A sub 8 is equal to 3 times 8 is 24 minus 1. So, A sub 8 is equal to 23. This is now your 8th term. For A sub 10, you are going to substitute 10 to n. So, 3 times 10 minus 1. A sub 10 is equal to 3 times 10 is 30 minus 1. A sub 10 is equal to 29. For A sub 15, we have 3 times 15 minus 1. So, A sub 15 is equal to 45 minus 1. A sub 15 is equal to 44. So, these are the answers. We have A sub 6 is equal to 17, A sub 8 is equal to 23, A sub 10 is equal to 29, and A sub 15 is equal to 44. And the general term of the arithmetic sequence is A sub n is equal to 3n minus 1. Let us try another example. Given the arithmetic sequence 15, 0, negative 15, negative 30, negative 45, and so on, Find the general term or the arithmetic sequence rule. Find a sub 6, a sub 8, a sub 10, and a sub 15. So the same process from the previous example, you're going to use the general rule a sub n is equal to a sub 1 plus n minus 1 times d. Now, from the given arithmetic sequence, you're going to identify the first term. So, that is 15. So, a sub n is equal to 15 plus n minus 1 times the common difference. So, you can choose two succeeding terms. So, example, let us use 15 and 0. Succeeding term minus the preceding term, that is 0 minus 15, that is equal to negative 15. So, the common difference is negative 15. So, let us substitute here negative 15 to d. Then, simplify. A sub n is equal to 15 plus, by distributive property, n times negative 15, that is negative 15n, plus negative 1 times negative 15 is 15. So, let us simplify. 15, this is equal to minus 15n plus 15. So, a sub n is equal to, we can combine 15 and 15. So, 15 plus 15 is 30, copy minus 15n. This is now the general rule or the general term for the arithmetic sequence 15, 0, negative 15, negative 30, negative 45, and so on. Now, let us find the sixth term, a sub 6. So, from this is equal to a sub 6 is equal to 30 minus 15 times 6. So, a sub 6 equals 30 minus 15 times 6 is equal to 90. So, a sub 6 is equal to 30 minus 90 is equal to negative 60. This is your sixth term. For the eighth term, we are going to substitute 8 to n. So, that is 30 minus 15 times 8. So, a sub 8 is equal to 30 minus 15 times 8 is equal to 120. A sub 8 is equal to 30 minus 120, that is equal to negative 90. This is your 8th term. For your 10th term, this is equal to 30 minus 15 times 10. So, a sub 10 is equal to 30 minus 15 times 10. This is 150. A sub 10 is equal to 30 minus 150. That is negative 120. For your 15th term, a sub 15 is equal to 30 minus 15 times 15. A sub 15 is equal to 30 minus 15 times 15 is equal to 225. Subtract 30 minus 225, that is equal to negative 195. So, this is now your 15th term. Now, let us discuss arithmetic mean. Arithmetic mean are terms m sub 1, m sub 2, up to m sub k between two numbers a and b, such that a, m sub 1, m sub 2, up to m sub k, b is an arithmetic sequence. Suppose we have 5 terms, a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. A sub 2, a sub 3, a sub 4 here are the arithmetic means between a sub 1 and a sub 5. This is your arithmetic mean between a sub 1 and a sub 5. Suppose we have 3 terms. We have a sub 1, a sub 2, and a sub 3, your arithmetic mean here between a sub 1 and a sub 3 is your a sub 2. If your arithmetic mean is between two numbers, this is sometimes referred to as the average or the mean. Okay, how to find or insert arithmetic mean or arithmetic means between two numbers? Okay, let us first take this example. Insert the missing term from the arithmetic sequence 5, 11, 17, blank, and 29. So what will be the number after 17 or before 29? So you are going to get first the common difference. So you can subtract two succeeding terms. Say for example, 5 and 11. So we subtract 11 minus 5, that is equal to 6. So your common difference is 6. Now, to get the term here, we simply add the common difference to the previous term. So that is 17 plus 6 is equal to 23. So the missing term here is 23. Another example is you're going to insert 3 arithmetic means between 6 and 54. So 6, insert 3 arithmetic means, and 54. So in this case, first term is 6, a sub 2, a sub 3, a sub 4 are your arithmetic means, and 54 here is your a sub 5. So we are going to find the second term, the third, and the fourth. We can use the general term or the general equation to solve for D. The a sub 1 is equal to a sub 1. The a sub n is equal to a sub 1 plus n minus 1 times D. Since your last term here is 54, that is your a sub n. This is the last term. We can substitute 54 to a sub n. Your first term is 6, so this will become 6 plus 54 is your fifth term. So 5 minus 1 times D. 54 is equal to 6 plus 5 minus 1 is equal to 4. So times D, this will become 4D. We can subtract both side by 6 para ma-eliminate itong 6. Matitira dito is 4D. 54 minus 6 is 48. Then we divide both side by 4. Cancel ang 4. So D is equal to 12. This is now your common difference. We can also use the method, yung kanina, yung D, given two non-succeeding term. So we have here a sub 1 and a sub 5. So a sub 5 minus a sub 1 over 5 minus 1. So ang a sub 5 natin is 54, a sub 1 is 6, 5 minus 1 is 4. D is equal to 54 minus 6 is 48 divided by 4 is equal to 12. So D is equal to 12. Ito yung second method in finding D. Now, since we already have the value of D which is equal to 12, we can now insert the 3 arithmetic means. So, by adding the constant term or 12, itong 12 sa preceding term, we can obtain yung next term. So, 6 plus 12 is equal to 18. Then, to get the next term, we also add 6. So, we also add 12. 18 plus 12 is equal to 30. Plus 12 again is equal to 42. Then, the next term is 54. So, the 3 arithmetic means between 6 and 54 are 18, 30, and 42. Now, let us try another example. Insert 4 arithmetic means between -3 and 12. So, since we are going to insert 4 arithmetic means, 1, 2, 3, 4, 12. This is your first term, second term, third term, 4th term, 5th term, and 12 is your 6th term. So, to solve for D, we can use the second method. So, that is your last term, A6 or A sub 6 minus the first term, A sub 1 over. A sub 6 is 6th term, so 6 minus A sub 1 is the first term, so minus 1. Your A sub 6 is 12 minus your first term is negative 3. 6 minus 1 is 5. 12 minus negative 3 is 15 over 5. 15 over 5 is 3. So, the common difference is 3. Now, we can obtain the next term by adding the constant term 3 to the previous term. So, negative 3 plus 3 equals 0. Plus 3 is equal to 3. Plus 3, this is 6. Plus 3, this is 9. Plus 3, we got 12. So, the arithmetic means, or the four arithmetic means between negative 3 and 12 are 0, 3, 6, and 9.